let's do so. This is a cube based on doubling, okay? All right, I'm going to ask you a question. I'm going to give you $1 million straight up, or you've got to choose A or B. I'm going to give you $1 million straight up, or I'm going to give you 1 cent on day 1, 2 cents on day 2, 4 cents on day 3, and we're going to just fill in the checkerboard. Would you like the $1 million, or would you like the 1 cent, and then the 2 cent, and then the 4 cent? Which one do you like? Why?
I've done this before, but I can't remember the reason behind it.
Ow. Any others? What do you want, the million?
Yeah.
You want the million? Straight out, $1 million there, or you just get 1 cent if that was 2
No,
cents.
but it goes up double every time.
It does, but how
Yeah.
long are you going for?
Do you know how long?
Forever?
No.
10 squares in, you're well over the million. By the time you've gone 2 to the power of 10, you're well over. 1, 2, 4, 8, 16, 32, 64,
Oh, because you're
128, okay?
Oh.
256, 500, 1,000. Yeah, 1,012, yes? 1,000, 2,000, 4,000, 8,000, 16,000, 32,000, 64,000. I'm just at the end of the first row.
Yeah.
I'm on 64,000, 128,000, 256,000, 512,000, 100,000. I'm halfway through the second row, 100,000, take it all the way through. You're up to $1 million. Well, in about the third or the fourth row.
Yeah.
Then, $1 million, 2 million, 4 million, 8 million. Can you feel that? It's rather lovely because this box shares the same. What did I do here? I went 1 doubled is 2. This is base 2. Because you can't have 2 in base 2. This is binary, you can't have 2, right? It goes 1, 10, 100, 1,000, yes? This is base?
3.
Good. 3. 1, 2, 10. Yes?
Yeah.
20, 100.
Mhm.
200, because you know hundreds are flat, right?
Yeah.
200, 1,000, nice. 1,000, 10,000, 10,000, 100,000, you know hundreds are flat, right?
Yeah.
Million.
200,000.
And $1 million.
See, you said I was.
Emma, do you understand why we teach it now?
Yeah, I was just wondering how I could use if I would ever use it, but I probably.
The use is in the beauty of the math system that human minds have created, because you can see that this is only in base 3, point line, plain, solid, point line, plain, solid. The colour system that you've been so used to, green, blue, red, all of that, you know how it works. Here you have it, base 3. But base 2, it's a little bit smaller, hey? What does base 4 look like?
Bigger. Of course.
5, 10.
Whoa.
Can you imagine 10? And in fact, some of us did do the million. We found the hierarchical material in Bex's room. And how big is a million? We 10 stories up if we started off with a 1 centimetre. Yeah?
So this is called hierarchy.
And I was interested
In different places. Hierarchical materials in different places. Yes. Hey, can I add in different bases? I've shown you I can here. I wonder what 2 plus 2 base 3 is. In base 3, what's 2 plus 2?
11.
No, it's 2 plus 2 is 11. Okay, yes, I get it. Because you get your 10 and then you have your 1. Yeah, got
Pass me
it.
that up, This is the red board.
Because it's
Just saying. Okay, let me start off with just 1. We're all good with, okay, we're all good with 1.
Yes,
We're all good with 2.
yes.
I want to add on 2 plus 2, but we're in base 3, right? I want to add on another one, what happens?
It becomes a 10.
Becomes a 10, all fair? I want to
Yes.
add another one now on 4.
Yes, so that's 11.
2 plus 2 base 4, and you do base 4, you just put a level 4 at the bottom, is 11.
What was that?
Base three.
2 plus 2 base
Base three,
4.
sorry,
Base
base
3, yeah.
It'll be 3 at the bottom, yeah, sorry, yeah.
Okay.
I wonder what 11 times 2 is in base 3.
11 times.
What's that? So that is not 100.
Oh,
That's
No,
fine,
base
because it's
three,
not base
it's
3,
okay.
so that's alright.
We're okay?
yeah,
Oh,
So
yeah.
it's 22.
yeah.
Yeah? 11 times 2 is 22.
Yeah.
2 plus 2 is 11. 11 times 2 is 22. What's
2 plus 2 is 11. Yeah.
and now what does 11 mean?
Anything, like,
What does 11 mean in base 10?
1 unit more than 10.
yeah.
1 unit more than the base. And that is special, right?
Yeah.
11 is cool. Remember I chose my number as 9?
Yeah.
Because it was 1 unit less than the base. Like it was really significant. It's the biggest number you get, 9.
It's
Very
base
cool.
10.
In base 10. Now we're having to spend most of our lives in base 10, which is handy. Handy. What am I doing if I multiply by 3? Should we take 11 times 3? In base 3. In fact, it's 11 times 10. Because with base 3, you can't have multiplying by 3, but don't let it stress you out, okay? 11 times the next thing after 2 in base 3 is?
200.
Can you imagine I need another one? I need
Yes.
another one.
So that'll be
Okay, I've got that there, but I'm going to put this in here and take a 1. So there's 1 there, 1 there, and 1 there. True?
Yeah.
Yes? 1 there, 1 there, and 1 there. Well, that means that I need one of those. But I can't do a one of those, so I need a one of these.
Yeah.
We can have that there. So this is right, isn't it? Then?
Yes.
This is 101. So 2 times 2 base 3 is 11. 11 times 3 base 3 is 101. Yeah. And then you build it up.
Was it 110?
100 and,
Yeah.
where did I put this before? Where did I should have put this? They should be here.
Yeah.
So 110. Yeah, thank you. Cool.
I was like, what's happening?
Play with it. This is a beautiful piece of equipment. All right, we'll just leap. Because you think you understand the world, I'm just going to leap into the 4th and 5th dimension. Just to prove that you don't.
We saw the third.
This is okay.
This is going to be fun.
Sure, but you haven't put them into the same base too. You'd go, what's 4 base 5 plus 6 base 4? You could put choose any base you want. All right, you have to imagine for base 4 that base 4 we're going to call 2. It's kind of odd, but we have to. I took a unit. Actually, it might be easier if I have a trinomial cube. Is there a trinomial cube?
This is the earthy looking one, right?
the
Or on the actual one?
Actual one would be better, I think, because they are built on the same colour schemes. This one.
I still try to get my head around it.
Nice feeling. You thought that what you knew all there was to know in maths for primary school.
I think I want to reword my question. Not why are we learning it, but why does it exist? Why did they create this
Because
force
it
that-
does exist. It exists as much as 10 exists.
which means it doesn't.
Well, it just means that we all agree that it's just 10.
In
We
our
could
circus
easily
tent.
have chosen 2. Why are police cars black and white? We could easily have chosen orange and green. Easily. Precisely. Like, we get to choose. And you think that there are only some things that we choose, but there's some things are absolutely true. And I'm saying maths is not one of those absolutely true things. Maths is one of those we get to choose things. Isn't it?
Well, it's drilled into you that it's like, this is the truth. But mainstream, that's what I felt, like this is either wrong or right. There's no other. But this, it's like, well, if you're wrong, you're wrong. Who cares? It's good. Like, I did that 6
No,
times.
you do care. Shana, how did it feel not to get her out?
I still could, but it was like, I know that there's something that I need to kind of
fix or work on.
Yes.
It wasn't like I'm wrong so I can't do it. It was just like there's something that I need to do differently.
It wasn't that you could walk away and just say, oh,
Yeah.
you did care. In fact, you
Yeah.
cared deeply. You slept
Yeah.
with the ideas, right? So we have to be careful. These are very important ideas to us. They're very central to who we are, but they're just man-made ideas in the same way that the inch is a man-made idea. Thank you.
Do you know if the binary code was invented before they started using it in computer systems?
Yes, because the binary code comes in day and night. It's been there all of our lives. It's just a switch on or switch off. That's it.
Why is computers binary?
Because computers can only go on or off.
Oh, okay. Yeah.
Yeah?
Yeah.
A torch can only be on or off. It's just an electric pulse. Is it there or not there? In fact, it's not on or off. It's either there or not
Is it
there.
same like lights? Like electricity.
Electricity comes in waves, yes.
Yeah.
Alternating current specifically would go coming towards you, coming away from you, coming toward you, coming away from you. So you could interpret coming towards you as on and coming away from you as off.
Yeah.
Choose to. All right, in this game, I take a line, I take a point, and I run it along, and I make a line, right?
Mhm.
I take a line, and I run it along, and I make a plane. I take a plane, and I run it up, and I make a cube. You're all good with that. That's
Yes.
three-dimensional thinking we're fine with. What happens in the fourth dimension if I run a cube along?
You make a line.
But you're thinking in
You make a prism.
Okay. Oh, yes.
Oh, yeah.
There we go.
We're going to make it look like it's a prism, but it isn't actually a prism, because prism means we're still just extending in one of the existing dimensions. And we're not, we're actually in another. So we don't know what this looks like.
Yeah.
Logically it looks like what I'm about to show you, but it's an understanding, it's a human mental game we're playing, right? Of course the fourth dimension exists, but our brain can't see it. Let's go to Flatland. I'm a flat person. I live on flatland, right? And everything is just on a piece of paper. That's my whole world. I can walk around. I walk around like this. I can bump into something. I can't get around something if it's there. I have to go around. This is flatland, right? And I can see it. This is in 2 dimensions. And I can see that this has got a straight line, and then there's got an in bit here, and then I can sort of feel, and then there's a circle. I know what a circle feels like when I'm bumping into it, right? That's flatland. But what does a hand, my arm, reaching through flatland look like? So imagine flatland is this thin layer of dimension. I'm going to put my hand through it. Well, first of all, they would just see a circle that appear, and then suddenly that circle will get bigger. Remember, I can only see flat. It'll get bigger, and then suddenly there would be 3 circles appearing. Can you see? There'd be 3 circles appearing, and then suddenly there'd be 4 circles appearing, and there'd be these great big circles for a long, long, long time, and then it'll be turning into a great big flag oblong. It'll turn into a rectangle or like you did, yeah? And da-da-da. And then after a while, a 5th circle would appear somewhere over there. Can you see how weird it would be?
When you do a scan,
Yeah.
then you can actually see all the pictures of like your body and
Yes.
Yeah.
Yes, and if they do it fast, then it would be very odd to imagine what it would look like. So in flatland, 3 dimensions is really weird. In 3 dimensions, 4 dimensions is very weird. We just have to imagine what if it looked like. So we're going to imagine that. The 3rd dimension is 2. The 5th dimension is... It's so complicated to explain. I'm talking about to the power of 4. Okay? Remember to cubed, we've gone to squared, we've gone to the little 2 here. Cubed, we've done to the 3. Now we're going to go to the 4. The material wants, it makes some assumptions. It's going to make an assumption that this yellow, I'm going to like take it twice. Can you see that? Now it's not actually together like this. The second one is in another dimension, right? Yep, but I'm just going to put them together like this. Then I'm going to take this little dude here, and I'm going to make him twice as long. Yes? Fair enough. And then I'm going to make him also... Can you see I've sort of expanded him? I've expanded him, I've expanded him, and I've expanded him, or her. Then.
It.
Yeah? Then I have expanded this guy down the bottom, here. I've expanded, we're actually into 3 dimensions, so this is just on the top layer. This one into 2 dimensions, into the next dimension. It's not exactly right. It's hard for you to understand, because it is impossible to understand. Can you sort of see that I've got a 3-dimensional unit here, and whoom, I've sort of whoomped it out somehow. Does this make sense? Let me take another one here and whoomped it out. Yes? This blue here, can you see I've whoomped it out?
Mm-hmm.
But remember, when I expanded in my dimension before, I would go up, I would go out, I would go across. But I needed this extra dimensional stuff. The black ones here, which don't have any colour, they're not uniform, and now the white ones here. So we need to understand. You can't understand. Your brain is not geared up to understand. It's nothing about you. But the understanding can't happen. Can you see? You see I've whooped it out? See these 3, just let's look at these 3 to start off with. I've taken this one and I've whooped it that way. I've taken this one and I've whooped it that way. And I've taken this one and whooped it. It's the same block, but I've expanded into the next dimension by expanding. Does that make sense? I know you think it does, but it doesn't. Which is marginally irritating.
Cubing the cube.
Guys, yes, but it isn't. You go out of our dimensions. This is not what we were doing before. That was 3 to the x, or 4 to the x. This is x to the 4. We're in the 4th dimension. And just so you know, there's a lot of this.
Oh, God.
Okay? What I'm going to make a call is, I'm going to say, it's here, come and work with it. It is not necessary. Most schools do not have this. Okay? The idea of it is that you take an element and you expand it in 2 and then in 3 dimensions. There is a use of the colour system that goes all the way through, and you can prove it algebraically. If I ask you to do a plus b plus c to the 4, you would end up with this material. If I ask you to do a plus b plus c to the 5, you'd end up with this material. There's a challenge there if you like. There is a lot of challenges in this last section of mathematics. 2?
So how many dimensions does this material go up to? 5.
So your question is prove the 4th dimension using algebra.
Why don't you write a plus b plus c to the 4th, do it algebraically, and then find the pieces here. Remember that the 4th dimension is recognised as 2 in this. This is an assumption that I'm just calling it 2. And it will come out. It does actually form a rather beautiful, you can actually build it. I'm not going to now. It's very complex what we're trying to do, because you're trying to build in... Go and see the film. What's the film we have to see?
Interstellar.
Interstellar, yeah.
Yeah.
Interstellar. Starts to show you what it looks like.
What happens what happens to the
This
cube
is stuff you
next
don't
to
use.
it? What happens to the cube next to it? So if it's going
Yeah, exactly. You're trying to put it into a 3 dimension. It can't take up more room in our dimension. It actually has to leap into another dimension. But you think of the difference between 1 and 2 dimensions and 2 to 3, it's as complicated as 3 to 4, but it's only that complicated. Enjoy. Go and do the munch thing. Come back at 12:30. We will do, I've got 3 things I want to do, or maybe. Deconomial, absolutely. Stream, we talked about. The history of maths and maths curriculum. And we've got to put all this stuff away.
Cool. Yeah, and when you see Snake Game
With the 6 box. Oh.
If you'd like to do that, I can do that. The system. I'll just do it if you like when later. That's completely easy.
Guys,